number 15 and 16 on this video, and they're not really related at all. But number 15, at what points on the curve y equals sine x plus cosine x? And then this is just saying that your x's are only existing between 0 and 2 pi. So think about it as just being one rotation of the unit circle. At what points on that curve is the tangent line horizontal? Okay, so we're concerned about the tangent line, so we're going to find the derivative. So y prime is going to equal derivative of sine x, cosine x, derivative of cosine x, negative sine x. So that's our derivative, and I want to know when is the tangent line going to be horizontal, and that means that we have a slope of 0. So that means I want to find when is my derivative equal to 0. So I'm going to set cosine x minus sine x equal to 0. Now there are a couple ways you could go about solving this, but what I'm going to do is add the sine x to the other side so that it says cosine x is equal to sine x. Now again, I could continue to kind of manipulate here. I could maybe divide by the sine x so that I would get a cotangent of x equals 0, and I could think about that. But I'm going to kind of stop here and just think, the question is, when does cosine x equal sine x? So if I think about my unit circle, I'm looking for what are the angles where those two functions are the same. Alright, so if you look at your unit circle and try to figure that out, x is the angle where cosine x is equal to sine x is pi over 4 and also 3 pi over 4. So at pi over 4, they're both square root of 2. At 3 pi over 4, I'm sorry, not 3 pi over 4. At 5 pi over 4, they are both negative the square root of 2 over 2. So we've got one in quadrant 1, pi over 4, both positive, root 2 over 2. And then 5 pi over 4, that would be in quadrant 3, both negative there. Now, when you had this question in trig, when it was like solve this trig equation, you would say something like plus 2k pi, which would mean if I keep on adding revolutions to each one of those, I'm going to keep getting places where sine is equal to cosine. But that's where this comes into play, which says only give us the answers for x between 0 and 2 pi, which is just on the unit circle. Where are those places where the cosine of x is equal to the sine x? And that's going to be at pi over 4 and 5 pi over 4. So if you were to graph this function, you would see at pi over 4 and at 5 pi over 4, if you graph this sine x plus cosine x, you would see that you would have local max or mins. You would see places where the tangent line would equal 0. I'm sorry, the slope of the tangent line would equal 0. Number 16. We want to find the derivative of this function in terms of f prime and g prime. So I don't know what the functions f and g are, but I am going to find the derivative of h, and I'm going to use the rules that we know to do that. So h prime of x is equal to, well, what jumps out to me right away is that it is a quotient, so I'm going to start with the quotient rule. So I'm going to do the bottom, which is just going to be f of x plus g of x. I'm going to take that, and I'm going to multiply by the derivative of the top. Now the derivative of the top is f of x times g of x, which means I have a product here. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. So that's bottom times derivative of the top minus the top, f of x, g of x, times the derivative of the bottom. Now when I do the derivative of the bottom, I don't need to do any kind of special rules because they are being added together. So the derivative of the bottom is simply just going to be whatever f prime would be plus whatever g prime would be. So f prime of x plus g prime of x. So that's my numerator, and then all over the bottom squared, which would be f of x plus g of x squared. Looks really complicated there, but it's really just a quotient rule with a product rule mixed in there. But being able to find the derivative and understand what that looks like when you don't know the actual functions is just really helping to to hone in on the skills of using those rules, the quotient rule, the product rule, and the chain rule.